list of, I'm taking all the columns, I'm converting all the column names as list, and here are all the column names. Out of all these columns, the first 15, which is from 0 until 14 are inputs. The last one, which is 15, is a target variable, output. Will a person default or not? So I'm just segregating. I'm saying right from the beginning until this 15, all these column names will be part of predictors, and the last column would be a target variable. Then we are saying go to scikit-learn model selection. From that input, train, test, split. And then we are saying train, test, split. Take the data, and I want 30% of data to be in test data, and another 70% I want that to be part of my training data. In this train, test, split, what kind of split happens? Random split or sequential split? Random split. Always it is random split. That means I will have different data in training and I'll have different data in test. That also means that each time I run the algorithm, I'll keep getting different accuracy values, right? Because each time I split into training and test, I get different data into training, I get different data into test. When I build my model on training and test it on test, I might get different accuracies each time because the data will be different. Is the accuracy values fluctuating a lot? Each time I split the data, train on the training and test on test, would the accuracy values fluctuate a lot? Or would the accuracy values be close? Is something that you have to look at. If the accuracy values are fluctuating a lot, then you have to run this algorithm multiple times. And each time you run, it's going to split. And you'll be training on different data sets, testing on different data sets, because it's a random split. Do it at 10 times. For all the 10 times, take an average. That you will say would be my final result. And that's called as bagging. That is called as bagging in Ensemble techniques. We'll get there. Okay. So from scikit-learn, we import decision tree. Here we are using criterion as entropy. And then we're going to fit the model. When we fit the model, we are using predictors, which are nothing but inputs, and the output is target, and we run it. Okay. Once you build your model, what do we do with that model? We take that model and we predict on the test data. So we have data, which is split into training and test. And we already segregated the data into predictors and targets. Predictors are nothing but your inputs. And then you have your target, which is your output variable. So we have our inputs and outputs. Then when we are training, we are training it on inputs and output. We build the model. We take that model and we are trying to predict on the test data inputs, which are nothing but predictors. When you do that, you get predicted values. Now you are saying, let me go to test data target, which is the actual value, and let me compare it with the predicted values. Let the row names be actual values, column names be the predicted values. And create the crosstab. So 168 entries, which are actually no, have been predicted as no. 38 entries, which are actually yes, have been predicted as yes. So this diagonal would be giving you the right prediction results. 51 entries, which are actually no, are classified as yes, incorrect. 43 entries, which are actually no, are classified as no, incorrect entries, right? So the correct classification is 168 plus 38 divided by the overall count. What would that give you? Accuracy. Either do that manual calculation or do this. Predicted values, compare, double equal to means comparison operator. Compare it with the actual values. And if it is same, the result will be true. If they are not same, result will be false. How many times is it true? 0.686. So 66 is the accuracy. Now, whenever we build the model, what should we also do? We should, after you build the model, we predict it on the test data, but we also have to predict on the training data, right? So that is what we are doing. Take the model, predict on the training data, predictors means inputs. Then you get the predicted values. Training data will have the actual values in target. So take that actual, compare it with the predicted values. Row names should be actual, column names should be predicted. So let me run it. Wow. Are there any misclassified entries? No. When you look at, or when you compare the predicted values with actual values, double equal to means comparison operator. If they are the same, you'll get true. If they are not same, you'll get false. On an average, how many times you have true? Oh, 100%. Training accuracy is 100%. Test accuracy is 0.68. So what is happening? Overfitting. Overfitting means training accuracy will be high, test accuracy will be low. When your model overfits, what should we do? Apply regularization techniques. Yes. Here, either, say that minimum sample leaves equal to 1, run one algorithm. Minimum sample leaves equal to 5, run another algorithm. Minimum sample leaves equal to 10, run another algorithm. Minimum sample leaf equal to 20, run another algorithm. Save all the 5 model accuracies, training and test accuracies. Then experiment with maximum depth equal to 2, maximum depth equal to 4, maximum depth equal to 6, 8, 10. Another 5 experiments. Take the training, accuracy, test accuracy. Then try out with maximum features equal to square root. Then do this. If you keep doing this, there can be hundreds and thousands of experiments which you can perform. It is time consuming. Hence, we have something called as grid search cross validation. Grid search cross validation. And when it comes to decision tree, okay, here we have all the, I'm not sure why they're writing it as parameters. According to me, it's incorrect. But anyways, since they are writing it in this way, let's focus on this. These are all actually called as hyperparameter strings because you can try it with these 2 options. Splitter, you have 2 options. Maximum depth, you have different options that you can provide. So what this grid search cross validation will help you do is, it will help you experiment all of these things at one go. You define all of your hyperparameters and say that minimum sample leaves, maximum depth, maximum features, and criterion is entropy. Now, when you run your grid search cross validation, you say, I want this decision tree model to be run. When it comes to parameters, I want to use all of these parameters. I want accuracy as a measure to be used. I want to calculate accuracy. And then number of jobs equal to -1 means I want to use all the processes. You know what? We will have dual core processes. Means what? There'll be 2 processes, processor 1 and processor 2. Quad core means you'll have 4 processes, processor 1, 2, 3, 4. When you try to use all the processes at one go, it's called as multiprocessor, right? Serial processing, parallel processing, etc. Okay. So when you try to use multiple processes, it's called as multiple processor processing, or it is called as parallel processing. So you have all these experiments to be performed, right? Each experiment will be run on one of the processes in parallel. Not one experiment after another. All the experiments. So if you have, say, 16 experiments as an example, 4 will run here in this, 4 will run in this, 4 will run in this, 4 will run in this. So everything will get completed at one go. If you have serial processing one after another, it will take huge amount of time. If you say -1, you're saying use all the processes that we have. Then we have cross validation equal to 5. We have refit equal to true, return train score equal to true. Okay, let me explain here about cross validation. The other two, some other time. So cross validation equal to 5. What happens here? Let me explain. This is also a technique which is used to handle your class imbalance. Okay. Suppose you have a data set which has 10,000 observations. Okay. Suppose you have 10,000 observations. If you say, I want to do a k-fold cross validation in which I want to define the k value as 5. Then what happens is this entire data set will get split into 5 parts. Observation 1 until 2000 would be one part, part 1. 2001 until 4000 will be part 2. 4001 until 6000 will be part 3. 6001 until 8000 would be part 4. And 8001 until 10,000 would be part 5. So you have 5 parts, 1, 2, 3. And it will also have 5 folds. Fold 1, fold 2, fold 3, fold 4, and fold 5. If you have class imbalance, that means one of the classes will be less. Correct? Default, not default. When I say we have an imbalanced data set, then the default cases will be less. So your model will be learning less default cases. It's like you preparing for exam. If I give you only 5 questions from probability, all the remaining questions are from machine learning algorithms. That means you'll be learning less on probability because there are only 5 questions for you to prepare. The remaining all you'll be preparing on machine learning algorithms. So the learning will be more on machine learning algorithms. It will be less on probability. This is also seen. If you have less default cases, you'll be learning less of default, examples. So here what happens is in fold 1, out of these 5 parts, your model will be trained on part 2, part 3, part 4, and part 5. On these training happens. And when you test your model, you test it on part 1. For this part 1, you get the predicted values, actual values, compare, you get error, all that. Then in fold 2, you train your model on part 1, part 2, part 3, part 4, and part 5. And then you test it on part 2. In fold 3, you train your model on all the parts except for part 3 because you test on that. For fold 4, you train on all the parts and test it on part 2. And fold 5, you train it on all the parts and test it on part 5. So in some sense, you're training your data on all the parts and you're testing your data on all the parts. Okay, so that every observation, whether it is used more times or less times, gets equal opportunity to be tested, gets equal opportunity to be trained. Okay, so this is a technique which is used to handle imbalanced data set. And when I say cross validation equal to 5, that is exactly what is happening. Okay, you can always go to, this, you can always say help of grid search otherwise. List, I'm not sure. Let me see. Yeah. Okay, you have all these hyperparameters which will get generated. In this, you have refit. Okay. All these are the hyperparameters. For whichever hyperparameter you're giving the information, it will take only that. For remaining hyperparameters, it will use its own. Okay, here is refit. Refit an estimator using the best count parameters on the whole dataset. So what you're saying is train the model on all these different set of hyperparameters combinations, and then choose which combination is giving you the best result. Once you figure out those best found hyperparameters, train your model using those best parameters on the entire dataset. Okay, that is what we are seeing.